Today I'm here to present the technology that is fruit byproduct based active biodegradable packaging material. So first of all, why we are concerned about the plastic pollution? Because it is not only the problem of today's time, but it is also creating problem for upcoming 16 generations as well. 91% of this are not getting recycled. 99% of them are causing climate change. We are eating plastic, drinking plastic, even breathing plastic through the microplastic present in our environment. The major challenge today this industry is facing is the single-use plastic. The single use plastic is negligibly getting recycled and it has high leakage rate into the ocean. Around 80% of the single use plastic is getting end up in the ocean. So this crisis necessitates the development of bioplastic. But still there are certain challenges associated with it, like feedstock diversity, energy efficiency. It requires energy at different level of its production. End of life management, how it is going to end in our environment, whether it is getting degraded by itself or require any special kind of treatment. So how it is being addressed today? There are certain industries which are working with bioplastics, but still there are certain disadvantages associated with it. For example, in geoplastic produced by nature works, it is derived from corn starch, and hence this corn production is getting deviated from the food source to the bioplastic. Eco-flex biodegradable plastic, they're also producing from wheat, corn, sugarcane, and it is also deviating it from food source, and the bioplastic is not completely degraded in environment, natural environment. I am green ethylene. It is derived from sugarcane ethanol, and it is also not completely biodegradable. Matter B bioplastics, they're derived from starch, vegetable oils, and it requires specific condition for its degradation. Zero Circle industry is established in India, where they're deriving the bioplastic from seaweeds. It is biodegradable, but still they're facing certain problem like biosecurity risk, infrastructure cost. It requires huge amount of infrastructure for seaweed cultivation, labor cost. So, what could be the possible solution for this problem? One solution could be the utilization of natural polymers like cellulose, hemicellulose, pectin from the industrial waste, fruit processing waste. Here we have synthesized bioplastic from the fruit waste. We have used this fruit waste as the filler material. So due to addition of this filler material, we have got efficient antioxidant property into this bioplastic, UV light barrier property, and oil barrier property, which makes it as good food packaging material. From SEM micrograph, we can see that there is no cracks or pores in this bioplastic. So it justifies it that the filler material and cross-linking agent are homogeneously mixed in this plastic, and it also justifies its oil barrier property and moisture barrier property. This was tested and it's completely biodegraded within 15 days in natural environment. It could be cheaper as it is the base material used is derived from the fruit processing waste. This technology is still in the TRL 4 level, that it is validated in lab scale only. Patent has been applied for this, and major steps that are yet to be taken are scale up, prototype demonstration in operational environment, market development, and commercialization. So the market potential of the bioplastic was 11.2 billion US dollar in 2021, and it is expected to reach around 46.1 billion US dollar by 2030. Target customer for our technology are food packaging industries, cosmetic industry, and medical supply packaging industry, as they are producing huge amount of single-use plastic, and it could be substituted with this bioplastic as it has better UV transmittance property, oil barrier property, moisture barrier property, and agricultural mulch film. The synthetic ones are getting degraded in the agricultural soil, and they are causing microplastic in the agricultural soil. So by substituting it with this bioplastic, it could be beneficial. Scale of feasibility, production technology still requires bioplastic extruder for making pellets and sheets of this plastic. Feedstock availability will be there as it we can have sustainable supply throughout a year from the fruit processing industries. Approximately 75 to 100 per square meter of the sheet it will cost. This bioplastic will cost. So the constraints that are associated with this, time to TRL, development of full-scale prototype is remaining, validation of its performance, qualify the testing through different applications, launching of the commercial product, market entry, monitor and improve. Equipment that are necessary are raw material processing equipment, compounding and extrusion equipment, molding and shaping, quality control equipment according to the application that we are going to use. Funds requirement and initial investment, funds for research and development, operational fund and funding models are yet to be generated. These are the manpower that would be required for initial startup of this technology. The transfer of the technology will be done in a collaborative process by discussion with our institute, and it will address all the aspects of implementation, support, and necessary agreements. Thank you.